Dimensional analysis is a method for solving problems. And we teach the method because it helps us find the answer by looking at units. Oftentimes it is called unit analysis. Once we have the units that we want to be in, we know that we have the answer correct. An example of this is with a common problem that most of us know how to solve in our head, and that would be, if a person is 5 feet tall, what is their height in inches? Well, as we all know, there are 12 inches in 1 foot, and so we would just simply take 12 times 5 and get 60 inches. But to use the method of dimensional analysis to do this, we're going to set it up in a sense like fractions, and we're going to get undesired units to cancel out so that we end up with desired units. The way I set it up is I'll put 5 feet on top. I use just the lines to make it simpler and faster, and then I use my conversion factor of 12 inches equaling 1 foot. My undesired unit of 1 foot goes on bottom. My desired unit of inches goes on top. And remember, it is 12 inches that has to stay with 12 and inches, and 1 stays with foot. The foot unit cancels out. Because both numbers are on top, we multiply, and we know we get 60. We can't forget about significant figures, nor can we forget about units, so we go back, and because we did multiplication, we look at total significant figures. Our given has 2 significant figures, and this conversion factor is an exact conversion factor, so we don't worry about significant figures with it. So our answer must have a decimal to show that it has 2 significant figures in our unit of inches. So our answer then is 60 decimal inches. We are going to use this process of dimensional analysis to solve metric conversions. And the way I do that is I memorize my metric prefixes. And by memorizing my metric prefixes, I know that I can calculate any metric conversion within this scale, because I have learned that my large prefixes and my small prefixes have a relationship. Between each of these spaces is a power of 10. So if I want to determine how many millimeters, let's say, are in 1 decameter, then I just simply count. I don't count where I'm standing, just like you don't count start on a board game, but I say 1, 2, 3, 4 spaces. That means 10 to the 4th. And I always look at how many small prefixes are in 1 larger prefix. So whoever is lower in my chart has the power. Whoever is higher in my chart is going to be 1. I always do my conversion factors with metric prefixes in this manner. So the first thing we're going to do on this sheet is we're going to determine our conversion factors for these metric prefixes, practicing what I've just done. We're looking at a relationship between meters and kilometers. Most of you know 1,000 meters are in 1 kilometer, and that's wonderful that you know that because you've memorized it. But let's learn how to do it in my method. Remember, base is meter, liter, gram, or it could be any number of things. Meter is lower in my chart than kilo is, so that means we're going to have 1 that goes with kilometer. Here's meter, so we count 1, 2, 3. That's 10 to the 3rd meters in 1 kilometer. We're going to determine all of these conversion factors, then we'll come back and do the dimensional analysis. Here we're looking at a relationship between kilograms and milligrams. Milli, kilo. Who's larger? Kilogram is larger. So 1 kilogram equals, here's milli. We don't count milli, but we count above that. 1, 2, 3, 4, 5, 6. 10 to the 6 milligrams are in 1 kilogram. Relationship between hectograms and centigrams. This is an unusual relationship that you probably didn't memorize, but it's easily determined by my method. Who is lower gets the power. So centi is going to get the power. Hecto you will have 1 of. So 1 hectogram equals, here's centi, 1, 2, 3, 4. That's 10 to the 4th centigrams equals 1 hectogram. Relationship between nanograms and grams. Again, we can see that grams is larger, so it will be 1 gram equals, nano is all the way at the bottom. These are spaces. We don't know the names of these prefixes, but we do know that there's a power of 10 here, so we must remember that the space is here. When I say these aloud, and I've memorized these, I say kilo, hecto, deca, base, deci, centi, milli, space, micro, space, nano. I'm looking then at nano. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 to the 9th nanograms in 1 gram. DA is deca, decaliter, 2, and this little symbol is the Greek mu. It's a micro symbol. Again, not one you probably memorized, decaliter to microliter. Here we are at micro, here we are at deca. So who's larger? Deca. So that's going to be 1 decaliter equals 1, 2, 3, 4, 5, 6, 7. So 10 to the 7th microliters. Once we know our conversion factor, solving the problem is simply using the method of dimensional analysis. And the method of dimensional analysis is you always start with the given. This is the starting point. The given is our starting point. So in this case, it was 5 feet as our given. The conversion factor is here, and again, we've determined the conversion factor for each of our examples. So 12.7 meters is our given. So 12.7 meters is our given. We've already written our conversion factor down. 10 to the 3rd meters is in 1 kilometer. We want kilometers, so 1 kilometer will go on top. 10 to the 3rd meters goes on bottom. Meters cancel. Do the math. To plug this in your calculator, if you cannot do this in your head, which is not a problem, bring your calculator over, and on the TI-30X calculator, to plug in 10 to the 3rd, you're going to use this y to the x key. So we will enter this in as 12.7 divided by 10, y to the x, 3. The reason we divided is because the 10 to the 3rd was on the bottom. Anytime you have numbers on the top, you multiply. Anytime you have numbers on the bottom, you divide. The answer we get is 0.0127. So we will write 0.0127 kilometers. If I wanted that answer in scientific notation, then I can do that by hand and simply go 1, 2 places to the right. This is a very small number, so I know that's going to be a 10 to the negative 2, and the answer would be 1.27 times 10 to the negative 2. But my calculator can do that for me as well. On the TI-30XA, if you see SCI above the 5, you have this number written. You simply put second, 5, and it put it into scientific notation for you. 1.27 times 10 to the negative second. .18 times 10 to the negative 4th kilograms is our given. Our conversion factor, 10 to the 6 milligrams equals 1 kilogram. I want milligrams, so 10 to the 6 milligrams is going to be on top. 1 kilogram goes on bottom. Kilograms cancel out. Mathematically, if you remember your math rules for powers, a 10 to the negative fourth times a 10 to the 6th is going to be a 10 to the second. Again, if you don't remember how to do that, use your calculator and know how to properly use it. We're going to take the calculator back out of scientific notation, put it into floating decimal, which is second 4. The FLO at the top of the 4, second 4, gets it into floating decimal. The way you enter in scientific notation in your calculator is with this EE key. EE means times 10, so you don't hit times 10. Instead, we will plug in 8.18 EE for negative, and you can put the negative before the 4, times 10 y to the x 6. And the answer we get is 818. Or, as I said, 8.18 times 10 to the second by our math rules. .70 hectograms is our given. 10 to the 4th centigrams will go on top because we want centigrams. 1 hectogram goes on bottom. Hectograms cancel. There is no need to pick up a calculator on this. Simply write it in scientific notation exactly what you have written, and that is 3.70 times 10 to the 4th centigrams. Anytime you have a number greater than 10 to the 3rd, I would definitely advise putting it into scientific notation. In this case, however, in order to maintain significant figures, you must put this number in scientific notation. As you note, each of these did not change significant figures just by doing a metric conversion, because metric conversions are exact. 12.7, 3 significant figures. This has 3 significant figures. Remember, these zeros are not significant. 3 significant figures. Again, 8.18, 3 significant figures. Both of these have 3. In this case, you must write the answer in scientific notation. There is no other choice. 3.57 times 10 to the 7th nanograms. Our conversion is 10 to the 9th nanograms in 1 gram. So 10 to the 9th nanograms goes on bottom, 1 gram goes on top because I want grams, and nanograms needs to cancel. Mathematically, when I divide, I subtract. Again, if we don't know what we're doing mathematically, we use the calculator. 3.57 EE 7 divided by 10 y to the x 9 equals 0.0357. I can put that in scientific notation on my calculator if I choose, and we get 3.57 times 10 to the negative 2. Significant figures, again, did not change. 3 significant figures. This is 3, and we have 3. The last example is a very, very small number. And we're going to convert from from deciliters into microliters. So 10 to the 7th microliters goes on top. 1 deciliter goes on bottom. Deciliters cancel. In this scenario, you can put this into scientific notation, then mathematically calculate the power, or simply plug it in your calculator. 0.000435 times 10 y to the x 7 equals, and we get 4.35 times 10 to the 3rd. The significant figures are correct because these zeros in front were not significant. So 3 significant figures, 3 significant figures. Now let's do some dimensional analysis problems that may or may not include metric conversions. The principle is the same. We have conversion factors that we have learned. Some of you know a conversion between pounds and kilograms. Some of you know that as 2.20 pounds equals 1 kilogram. Others of us know 454 grams equals 1 pound. Still others of us know 453.6 grams equals 1 pound. Because this video is for students in several different classes, you will have to use the conversion factor that your teacher told you to use. I'm going to do this with using 454 grams in 1 pound. You will change the answer accordingly based upon which conversion factor you used. Chances are the final answer, because it will only have 2 significant figures, will be the same. Our given is 23 pounds. We are desiring kilograms. If you know the 2.20 pounds in 1 kilogram, you would simply put 2.20 pounds on bottom, 1 kilogram on top, take 23 divided by 2.20, and you would have the answer. I said I was going to use 454 grams in a pound, so that will be my next step. 1 pound will go on bottom, 454 grams goes on top. That does not give me kilograms, but I know that I can go from grams to kilograms doing a metric conversion. If I remember that there are 1,000 grams in 1 kilogram, then I simply add it to this last step. If I don't remember, what I have remembered are my metric prefixes. So I will go over and I will say kilos bigger, so that's going to be 1 kilogram. Here's gram, 1, 2, 3, so that's 10 to the third grams in 1 kilogram. So 10 to the third grams on bottom, 1 kilogram on top. Grams cancel. Pick up my calculator. I'm going to take it out of scientific notation and put it in floating decimal. Anytime a number is on top, I multiply. Anytime it is on the bottom, I divide. On my calculator, I get 10.442 kilograms. To show you again how I did that, 23 times 454 divided by 10, y to the x, 3. If you are using a TI 30X2S calculator that has the 2-line display, you do not have a y to the x key. Instead, on the left-hand side of your keyboard, you will have what is called a caret key. It looks like this. That will be the button that you will hit for your 10. That'll be the y to the x key. Significant figures. 2 significant figures for our given. The given usually counts for significant figures unless it specifically says exactly. 3 significant figures for this conversion factor because it is not exact, and all metric conversions are exact, so it doesn't count. So our answer should have 2 significant digits. Does the 4 make the 0 go up? No. Then we have a problem with 0. We must put the decimal to show that that 0 is significant. So our answer is 10 kilograms. Go to our next example. There again are more than 2 ways to do this problem, but we are going to do this problem with a conversion that we have learned in one of my classes of 946 milliliters equals 1 quart. Some of you have learned 946.4 milliliters equals 1 quart. If that is what you've learned, use that conversion factor. How do I even know to start here? That's a question many students have. How do you know that you're going to even use this conversion factor? Well, sometimes it's helpful to do a road map. And a road map is actually just units, so I don't put my given in the road map. I'm just going to put units in my road map. Because in the road map, I know where I'm starting unit-wise. I know where I want to go unit-wise. Then I figure out anything I know between the two of these. What do I know about cups? What do I know about milliliters? Well, let's say I don't remember milliliters and quarts, but I do know cups and pints. So that means that I can go pints to cups. Well, I know something about pints and quarts, so I know that I can do pints and quarts. Hopefully at that point, something will click and you'll say, oh yeah, I think I remember there was a milliliter to quart, which then will be milliliter to quart. I've put a little too much room here. Once you know your roadmap, then you start with your given. So 59 milliliters is my given. I know 946 milliliters in 1 quart. Again, if you are in a class where your teacher says 946.4 milliliters in 1 quart, then you must use it here. Milliliters cancel. Now I'm in quarts. What do you know about quarts? We've already decided we're going to go to pints. So I know that in 1 quart there are 2 pints. Quarts cancel. Why did I put quarts on bottom? Because I wanted quarts to cancel and I wanted to be in pints. What do I know about pints? I know there are 2 cups in 1 pint. So I'm going to put 1 pint on bottom, 2 cups on top, so that pints will cancel, and look, there's cups. If your unit ends up being correct, chances are you have the problem correct. Plug it in your calculator. Remember, multiply the top, divide by the bottom. 59 divided by 946 times 2 times 2 equals. And on my calculator, I get 0.249471459. How many significant figures should I have in my final answer? To decide that, you go back to original numbers. So I go back to my given, which had 2 significant figures. This is a not exact conversion factor, so it has 3. This is an exact conversion factor and exact conversion factor. My answer has to have the least because this is multiplication and division, so the answer should only have 2 significant figures. Here are my 2 significant figures. Does a 9 make a 4 go up? Yes, it does. So 0.25 cups. The last problem deals with length, and it tells us that we have an approximately 112 foot tall building. We want to know the height in meters. So we're converting feet eventually to meters. This is not a conversion factor that I give my students, but what I do give them is 2.54 centimeters equals 1 inch. With this information, I can determine feet to meters. So I will go feet to inches, inches to centimeters, and then centimeters to meters. So I'll start with my given, 112 feet. How do I convert that to inches? We've already done that today. For every 1 foot, there are 12 inches. Feet cancel. To get from inches to centimeters, I remember 2.5 centimeters in 1 inch. So where will 2.54 centimeters go? It will go on top. 2.54 centimeters on top, 1 inch on bottom, inch cancels. Now I'm in centimeters. If I do not know the relationship between centimeters and meters, I will go back up to my metric conversions, and I find that there are 2 spaces between centi and base, which means that's 10 to the 2nd centimeters in 1 meter. Or 10 to the 2nd is the same thing as 100. Where will 100 centimeters go? On bottom. And 1 meter will go on top. Centimeters cancel, and there you are in meters. Plug it into your calculator. 112 times 12 times 2.54 divided by 100. And our answer, 34.1376 meters. Significant figures, approximately 112, that definitely means 3 significant figures. 12 inches are exactly a foot, 2.54 centimeters are exactly an inch, and metric conversions are exact. So our answer should have 3 significant figures, as in the least, which is 3. Does a 3 make a 1 go up? No. 34.1 meters.